Okay, ladies and gentlemen, it's good to see you. Thank you for joining us. It is a pretty big day, yeah? So 5 minutes ago, something big happened. What happened? What happened? Or what didn't happen? I'll say if something didn't happen for you 5 minutes ago, you are in for a penalty. Why? Because
The due date for P1 Gold just ended.
bingo! Today is the end of your Project 1, okay? Project 1, usually a pretty visceral project for most teams, for most students. You're being thrown into the deep end in a few different ways, right? You are learning possibly the first game engine that you've ever really known. You are doing programming, the likes of which you've never done before, visual programming via or versus textual programming, blueprints. And you have now made your own first VR app. So congratulations, well done. It is not an easy assignment at all, okay? Some of those tasks, right, pretty gnarly. The whiteboard task, right, time of day, you really have to think about composition. You have to think about how these components work in relation to the actors that the components are on, right? You have to figure out how the VR pawn works, right, to do the whiteboard properly. And all that architecture setup, right, that affordance interaction architecture we set up is not a simple thing. It's a fairly advanced thing that you might design and create yourself if you are more of a lead engineer, okay? So in a sense, you are doing stuff that would not really be expected of you for years into your first job, okay? This is all to say that I'm very impressed and I'm proud of you, and I hope it hasn't been too burdensome or too nasty, okay? This course, in particular, in relation to EECS 494, is meant to be a little bit more chill, okay? And so hopefully you found that to be the case, maybe not toward the end of the project, but for most of the project, okay? One thing I'd really like to do, I didn't have time to go through and pre-look at all of these, but you have your P1 golds in the Discord, okay? There's a reason we do this, so we can all look at all the stuff and enjoy it. Did anyone in here make the little pig one right here, this one? Anyone? Okay, what is your gold? Your gold task, your gold feature?
We made basically a hunting game, but
A hunting game?
Yeah, if you click on the back door,
Okay.
Skip to,
Okay, so click on the back door. So there's the whiteboard. There's a back door with a portal on it, okay? It's glowing. Nice material. Survive the countdown. Oh my goodness. Is this the back rooms? Oh.
So there's two ways to get out of here. One is to survive the countdown.
Okay.
You get like a missing assignment.
Ah, brutal, brutal. Is this the manifestation of the autograder demon, maybe? Okay. You feel like you're trapped and time is running out and you just can't get those darn test cases. They're just wrecking you, right? Very cool. I like it a lot. And I know those feelings, right? I went through those assignments. I remember being in the laboratory as the deadline for EECS 281 was coming up. And people were very stressed, right? It was a very, very difficult environment. But sometimes people would do a submit and they'd get all the points and there'd be eureka, right? And everyone would kind of look at them with envy, right? And then go back to being nervous. So those emotions that you feel going through these courses, capture that stuff if you can. Everyone knows that there's no demon in the autograder. But sometimes it feels like there is. It legitimately feels like there is, which is to sometimes say, sometimes these virtual realities we create, they're a little bit more real than the real thing, okay? All right, so anyway, super cool stuff. And what's this one with the dog? Do we have this one in here, team? Okay, what was your gold?
Basketball.
All right. I know you were working on dunking, right? Did you do that? Okay, got you. Beautiful. Oh, there we go. The sun is just flying. Okay. What is this wheel you're interacting with? It's a clock. Oh, got you. That's really cool. Okay. You've got a scoreboard. Okay. Do we get to see you do some basketball, shoot a hoop? Okay, let's go over here maybe. Here we go. Okay, shoot a hoop. And I think that's cheating. Okay, 4 points. You get 2 points a shot. Can it detect a 3-point shot?
No, I can figure out how to get the figure out this standard.
You would need to detect the moment when the ball leaves the player's hand, and you would need to basically capture that vector 3, that point in space. Then you can, if it goes through the hoop, you can just do the distance calculation, and if it's far enough, you say that's a 3-pointer. Super cool. Very, very cool stuff. And not a huge task in terms of implementation, I don't think, right? You're mainly doing collisions, right? You've got a grabbable object with some physics. But the effect is really, really cool, right? A lot of students play basketball on campus. They would absolutely love to see this. So well done, well done. Okay, does anyone have one that they really want to show off for our final one? Final one? Otherwise, I'm going to watch all these later, okay? What about, what's this, what's this dog doing? It's this cool dog. Anyone in here at the dog? Okay, all right, we're going to find out what that custom feature is. What is this? I'm looking at the previews down here. It's just crazy. There's a grass floor in the Beister building. Okay, got some NPCs we can talk to. Got a Shiba. Okay, printer. Yep, copier, duplicate objects. Yep. Okay, there's a whiteboard. There's this, it's a creepy monster. Okay. If you click on the monster, it does a fade to a new map maybe. Oh goodness, what is this? Oh, you got a chainsaw in your hand.
マキマさん、俺に心ってあると思いますが。
どうしてそんなことを聞くの?
We are in an anime, or we're in a leaky theater watching an anime. Oh, it's an exhibition. Oh, wow. So this is the kind of cool thing you might see at a cool anime museum in Tokyo, maybe. Wow. Super cool. Okay. Computer science and weebs, right? Like this. Okay? Super, super cool. Well done. You become Chainsaw Man or Woman. Super, super cool. The effort that you've put into these is very impressive. One of the reasons, so I was talking to a few of you and you said that P1 Gold is really great because it allows you to do your own thing, right? I love P1 Gold not just for the creativity I get to see, but also you're off the rails. You are kind of finally away from the spec, away from the spreadsheet, away from my hints, and you're kind of beating and cutting the path yourself, okay? And that is a fantastic, fantastic way to learn. It's also proof that, yeah, you're a lot more powerful now than you were a couple weeks ago when you had to just follow the hints to the T. Now you can actually go off and do your own things. And that's a really, really impressive deal, okay? And to do that all in just like 1 month, just 3 weeks, less even than a month, is completely amazing. So well done. Very, very good job, okay? So you do have one assignment that is released today, okay? Good news, it's a super easy assignment, okay? These post-mortem assignments, which you can see launches today and is due Monday, these post-mortem assignments are all about kind of giving you a chance to reflect on what just happened, okay? You just went through a pretty visceral development experience, and I'm guessing that certain things went pretty well for you and other things were a disaster. How many of you got wrecked by version control issues? Anyone? Okay, I know a couple of you in here did, all right? And because I helped you fix them. But on any given project, there are things that go super well, and you want to make sure they continue to go well on future projects. But there are going to be things that go poorly, and you want to try and figure out why they went poorly. And to do that, you have to go back and think about them. You have to spend some time. Why did we have such a poor P1 alpha, right? Did we not start early enough? Maybe one of our team members got sick. Maybe our version control messed up badly. Okay, when you go back and you think about the things that went wrong, you can fix them. And you want to fix them to make the future brighter, okay? So here's what you're going to do in this assignment. This is not a literature or English course, okay? We do not care about your structure. We do not care about your grammar. So long as we can understand what you are writing and trying to say, that's all we care about. What ideas do you have? What you're going to do is you're going to open up this Google document, make a copy of it, and you're going to answer these questions in a short essay, okay? The questions are not hard, and they don't have a right or wrong answer, so you can go through them very fast. Your mission is to get to writing this essay, and you just dump your brain, okay? Think about what happened the last few weeks and dump your thoughts and feelings. Speculate, okay? You're just writing as fast as your brain dumps stuff out. And I expect you'll be done with this in about 30 to 45 minutes, okay? This is done individually. This is not a team assignment. So you have some privacy here. The only person who's going to read these postmortems is you, because you're writing it, and myself, okay? I grade these all by hand personally. And a big reason why I do so is I want to know what your experience was like, okay? The course is designed to help you have a certain learning experience. And if you're not having that, maybe I can make some tweaks. So, yeah, I hope you enjoy these kinds of assignments. They're really relaxing. I know the idea of writing probably isn't every engineer's cup of tea, but I think you'll find these to be a bit cathartic, okay? If things went bad or they were frustrating, this is your chance to rant about that, okay? And I encourage you to take that opportunity. Okay, and that's all you care about in the next 5 days. Relax, get yourself rested up, and if you weren't able to watch the film with us last night, just a reminder that you do need to eventually watch Tron and get that essay submitted before the 24th, okay? So you got a couple weeks. You're fine. Okay, I also have a company for you today. Right, we've got Brand XR. This is a company that's fairly near and dear to my heart. I know the founders of this company. I've had lunch with them, Moody Mahatan, and very, very cool people. And they've hired a ton of my students, actually. This is a company that aims to make XR accessible in a zero-code way. Have you ever thought about how intimidating code is? You know what people think about when you mention code? What image goes into their head? The Matrix. Okay? They see those green symbols flowing down the screen. It's people think about people who can code. When they think about someone who can program, they think about wizards and witches. It is magic to them. Okay? In many cases. And so, if you want to allow the masses or allow a marketing team to be able to create XR experiences, like the kind of things you're seeing, XR murals, basic XR minigames, okay? How are you going to do that? Okay? When a marketer thinks of building XR stuff, they get worried. They think, oh, I'm going to have to hire an engineering team. We're going to have to pay millions of dollars to get this thing made. But Brand XR says, no, you can actually just use our tool. And you can build your own in a code-free way. So trusted by leading brands. Now, this is not super specific terminology. You do wonder if these are paying clients of the company. Some of them are. Or if it's just, this is a company we've interacted with and they kind of sort of liked us, but they haven't actually paid us yet. They've been around for quite a while, so my assumption is that they have been doing pretty well. This is a company, blah, 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 blah. E-commerce. Interactions with products that feature 3D AR models achieve 94% higher conversions. I want to see the paper, right? I want to see the methodology here, right? Usually companies never give enough information when they say something like this. But shoppers are 10 times more likely to purchase a product after visualizing it in AR, and brands are seeing 3 times more product engagement. Use case, try before you buy product visualizations, blah, 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 virtual stores. Training, okay, reduce accidents and training costs, right? So training and education, along with medical, are really big hotspots for XR right now, okay, where we see very tangible results coming out. Not wishful thinking of a metaverse, but actual humans getting trained faster on randomized scenarios that really matter. Anyway, that's kind of interesting. Marketing, okay? In this case, there is some sort of logo in the middle of the stadium, and if you point your phone at it, maybe prompted by the scoreboard, you get to see an interesting interactive situation, okay? Which might be very cool. Brand XR has a pro services thing that can happen. So what is this? If you don't want to use their tool, or you want something very big or very custom that their tool can't do, you can hire the team itself and they will build it for you. Okay? This is very similar to companies such as Obsess AR, which we've already seen this semester, which are basically like consulting houses. Your company GM does not have an XR team, so let's go and hire Brand XR to build something for us. Okay? That's something you can do. That's Moody right there, and at TEDx Detroit. Very cool guy. And yeah, pretty neat. Brand XR Studio. So I think I have, let's watch this real quick, and then we'll move on.
Make augmented reality using no code with XR Studio. Step 1. Import your 3D model, or choose from over 500,000 3D models on Sketchfab. Step 2. Set the real-world size of your experience. Step 3. Use new 3D tools to scale, reposition, or rotate the model. Step 4. This new feature allows you to customize your lighting to set the mood of your experience. Step 5. Customize your embedded 3D model in your studio experience by changing the background. Step 6. New AR features enable you to customize whether you want an image tracking or world tracking experience. Step 7. Click the share button to publish your experience. Step 8. Now copy your smart link or scan your custom QR code to share your experience with the world.
Yeah. Another super cool thing, you don't have to install anything to make this work. It will just work when you share the link with someone else. Something to think about here is that tools like this are kind of interesting philosophically. If you are a software engineer and you are building a tool that very, very visibly emphasizes no code, right? Why would that be really appealing to customers? No code, no code. What's scary about code getting involved? I've sort of kind of already said it, right? But as soon as you need to code something up in order to make it happen, what does that mean? Pricey, because engineers are not cheap. If you think about the engineers who worked on this product, they are cannibalizing their own role, okay? You have an XR developer who is building a tool to allow you to build things without XR developers, okay? And from that perspective, many software engineers, as they go to automate things, as they build tools using code that protect others from having to code, it's kind of a very selfless thing to do. Now, fortunately for us, there's almost always another thing that can then be automated after we've automated ourselves away. But it is something kind of interesting to think about philosophically. When you're a really good software engineer, you're going to take yourself out of the picture. Okay, that's what you do. So anyway, super cool tool made by some very cool people, and made by some Wolverines as well, some people in your position. So hopefully they will have success and they will expand and create more opportunities locally. That'd be super cool. They're based in Detroit. They're also they're kind of split between Detroit and Orlando, Florida. Orlando has a lot of defense contractors, a lot of entertainment companies, and a lot of brands down there. Okay, the theme parks, NASA, I think, is down there. And so, yeah, cool stuff going on. Realism is improving in the virtual world, okay? Metaverse kind of sort of failed because everything looks very cheap, okay? Cartoony avatars are great in the Wii era for entertainment. No one really wants to be that all the time. This is a podcast called the Lex Fridman Podcast, and I don't really watch it much, but they had a section with Mark Zuckerberg showing some very cool tech. Take a look at this.
This conversation with Mark Zuckerberg inside the metaverse. Mark and I are hundreds of miles apart from each other in physical space, but it feels like we're in the same room because we appear to each other as photorealistic codec avatars in 3D with spatial audio. This technology is incredible, and I think it's the future of how human beings connect to each other in a deeply meaningful way on the internet. These avatars can capture many of the nuances of facial expressions that we humans use to communicate emotion to each other. Now, I just need to work on upgrading my emotion expressing capabilities of the underlying human. This is the Lex Fridman Podcast, and now, dear friends, here's Mark Zuckerberg. This is so great. Lighting change? Wow. Light anywhere. And it doesn't feel awkward to be really close to you.
No, it does. I moved you back a few feet before you got into the headset. You were like right here.
I don't know if people can see this, but this is incredible. The realism here is just incredible. Where am I? Where are you, Mark? Where are we?
You're in Austin, right?
No, I mean this place. We're surrounded by darkness with ultra realistic face, and it just feels like we're in the same room. This is really the most incredible thing I've ever seen. And sorry to be in your personal space.
I mean,
we have done jiu-jitsu before.
yeah, no, I was commenting to the team before that. Even that, I feel like we've choked each other from further distances than it feels like.
Okay, so there's lots of fun to be had at Meta and Horizon Worlds and Mr. Zuckerberg's expense, and we will have it. But something to always remind yourself of, these companies, these teams, in trying to aim high. Hey, Mark Zuckerberg, it's silly that you're trying to make a metaverse where we're all going to live digitally. Well, it might be or it might not be, but in the meantime, in pursuit of that, we're going to get a lot of very impressive technology that will, even if the current wave of VR doesn't explode the way Mr. Zuckerberg wants, they're going to empower. These advancements will empower the next wave of VR and AR, okay? And so, very impressive stuff. Some things I want to point out. These headsets are pros, okay, the ones you've got in front of you, and they are connected to big desktop computers, okay? So these are not the kind of standalone wireless headsets like the Cosmos, like the Quest line, Quest 3, that are forced into cartoony graphics, okay? This has much more processing power behind it, and you can see how impressive the results can be when we can get access to energy and processing power. So the question is, how do we miniaturize this so that we can actually do this in a detached way from something as small as our glasses? I don't know. That's up to you all. I'm just going to be here teaching. So anyway, very, very cool stuff. And Apple had their own take on this as well, though not nearly as impressive. Let's take a look, I think. Remember this?
Dynamically reflects your face and head movements. So when you're chatting, people see your eyes, hands, and true expressions. To convincingly place content in your space took thousands of groundbreaking innovations.
Okay, yeah, I think that's actually all. So Apple had similar technology that basically they have information from the device on what your eyes look like and what position they're in. I don't think they have real-time information about how your body looks. But before you use the device, you actually need to turn the device around so it can look at you. And it can scan you and your body and what you're wearing and your face. And it uses that to kind of try and figure out what you're going to look like in all these different poses as you kind of turn your head a bit and as you move your mouth. And it tries to use some weird, funky AI business to make this kind of fake character. You can see that on the sides where they have less data, maybe everything is fuzzier, trying to kind of mask some of the issues that they have. Unfortunately, this might be the best it's ever looked, and it doesn't look amazing. Yeah, they're also, something to remember is that they don't have access to the same processing power that Meta did in that previous example. The Vision Pro, $3,500 headset, but it's a detached one, right? It's running on battery power. It uses mobile chipset, not your desktop deluxe GPU, okay? And so they had to figure something out, and this is what they figured out. A lot of people mocked it when it came out because it was a bit uncanny. It didn't work for many people very well. But it's still probably the best that it's ever been on mobile detached, on-device mobile chipset hardware. Hopefully they don't give up, because if they give up, that would be very sad. But anyway, yeah, still cool tech, even if it doesn't quite work. It's not quite consumer grade yet. Okay, I'll really quickly go through this. So augmented reality is really fantastic for pranksters, and this is a fairly relevant topic now that we are moving on to Project 2 soon. On Monday, I think we're starting Project 2. Might be worth thinking, what can you do with AR? Well, Pepsi apparently has a team or some partners they work with for AR experiments, and they decided to take over a bus stop in, I think, New York City, and they replaced one of the see-through glass panels with a monitor, okay, with some pass-through AR, and let's see what they chose to do with this. Okay. So they've got and they're really convincing people very effectively. Okay, so they have UFOs coming in. Okay, they have a tiger, I think, that walks by. That one looks fantastic. A balloon person coming down. A killer robot. A tiger. That one is scary enough and realistic enough that it forces someone to get up, right? That person was with a loved one, so that might have affected it a little bit. Amazing, right? So super, super fun stuff. Super, super fun. Here's a hardcore version of this. One thing I will say is that I love pranks, and I can be a bit mischievous myself, but you never want your prank to hurt someone. And you need to be very careful that this doesn't occur. So I want to show you a very hardcore prank. I don't know what part of China this is, but this is a famous tourist mountain in China that uses some augmented reality in the glass walkway that people walk on the entire way. Okay, let's take a look. you go. Okay. Those kids are way braver than I would be. The first time I saw this video, I freaked out from the other side of the world through a laptop screen. And very, very impressive. What I would say, though, is maybe at that one part that you know is going to crack, maybe make the guardrail just a little bit higher in case someone really freaks out or jumps into the air and maybe falls off the side to a very real death. That would not be so good. So, but very, very cool stuff and lots of fun to be had for pranksters out there. If that's you, think about what you might be able to do with the knowledge that you're gaining in this course, okay? But please do keep everyone safe when you prank them. All right, so assignments are due. P1 Gold, I hope it went well. It looks like it went extremely well. I anticipate the grades being through the roof on this one, so we'll have to see if that ends up being the case. Your P1 Project Management is due. P1 PM is a little bit of an unfortunate short name because you know what PM could also stand for? Postmortem, okay? And so note that whenever I see PM in this course, it's almost always project management, okay? Jira is not everyone's favorite program, but it is an industry standard. That is why we use it. We want to get you trained up and at least get you used to using the UI. If you wonder, well, why do we need to use Jira? What's the point? Well, on a 2-person or 1-person project, it's not essential. You can use other things like Trello, or you can just use a Discord chat or an email thread to get the job done. However, these things do not scale well. And so if you move on to having a bigger team, like on P3, you're going to have 4 to 5 people on your team. Or if you go to industry and you've got 10 people, 100 people, 1,000 on your team, Jira becomes the only way to manage that complexity with any sort of consistency or speed. Okay? And so we really do want to get you used to that. I've seen students get the job or at least get an interview because they listed Jira as one of their skills on their resume. Okay? It's funny to think about, but some companies and teams are so integrated into the Jira ecosystem that just hearing that, oh, this person's going to plug in to our system really well is going to get them excited, okay? Could be the thing that differentiates you. So we want to make sure you've got some of those skills, okay? P1 Postmortem is released. You know about that. But again, over the next 5 days, I mostly just want you to relax, okay? And don't think too much about 440. Unless you haven't submitted yet. In that case, definitely do, okay? So today, we're kind of in a little bit of a chill place. We don't have P1 going on anymore. We don't really need to talk about Unreal or VR much. And we haven't quite begun our Project 2 yet. So on Monday, we're going to introduce Project 2 very formally. I'm going to give you a bunch of starter code. I'm going to walk you through the initial integration of Mapbox into your Unity project. And we're going to implement some of the harder features together, just like we did on Project 1. But that's not here yet. So what I would actually like to do today, and this might be a little bit of a shorter lecture, okay? Right? It's a little bit of a new course. That's how it tends to go. I'll add some more lectures this summer. But what I'd like to do is I would like to introduce you to Unity, okay? I know you've already done your exploration AR and your tutorial AR assignments. But how many of you've used Unity before, but you don't really have a good feel for it yet, right? It's kind of like, it's a little bit funky, right? Don't know about that textual C# programming, okay? Maybe you did the tutorials, but you just kind of copy and pasted some code, right? You're just writing what I show you, but you don't quite understand why you wrote the code the way you did, okay? Well, I really want to give you a better feel for what Unity is under the hood and how you tend to develop things in Unity. What you're going to find is that there are a lot of similarities to Unreal Engine. Things tend to look and sound a bit different in their terminology, and the UI is a little bit different, but the overall way that you make things is kind of the same, okay? You think about what you want, and you think, is there a component that can get me there? And if there isn't a component that can get me there, can I write one that will, okay? And that's how it tends to go. That's how it tends to go in just about any engine under the sun, okay? And so what I'd like to do is I would like to show you how to build some basic stuff in Unity. Now, you don't need to memorize or take notes on any of this stuff. I would ask you to just sit back, relax, and enjoy, okay, as we make something together. And so this is Unity, and it is in many ways very similar to what you find in Unreal Engine, okay? In fact, I'm going to make this into Unreal Engine for you, okay? Do you remember the outliner view? The outliner view is called the hierarchy in Unity. It is, as you would expect, just a list of all of your actors in your scene. Now, in Unity, they're called game objects. Now, I'm going to take this hierarchy and I'm going to make it just like the Unreal Engine UI, and I'm going to put it up here, okay? Congratulations, you now have the Unreal Engine UI for the most part, okay? Your details pane in Unity is now called the inspector, all right? And it's down here. If I click on my main camera actor, game object, I'm going to fill up my inspector panel down here with all sorts of stuff. And just like in Unreal, it's basically just a bunch of components, okay? And you can open up any of these components, right, and see what is inside that component. The transform component is kind of sort of like the static mesh component, except it's only a chunk of it. You see, in Unity, if you have, for instance, a cube, I'm going to click this plus button in my outliner, in my hierarchy. I'm going to go to 3D object. I want a cube, okay? Here's my cube. All right, here is my cube. I'm going to move the main camera closer to my cube so I can see it a bit better, okay? This cube right here has a transform component, okay, with position, and I can click and drag and change the position however I want, okay? Rotation, right, and I can mess with that, and scale, and I can mess with that. However, it's actually different than a static mesh component because the static mesh component also handles collisions, it also handles physics and rendering. It does all that. Well, in Unity, Unity really likes smaller, tiny components that only do small things. So we've got one component for the transform. We've got another component for the mesh render right here. And I can actually turn the components on and off really easily with this checkbox to see what they do, okay? It's really obvious what the mesh render does when you turn it off and the mesh render is gone, right? The cube is invisible. And a box collider, okay? And so you can see that instead of one big static mesh component, we've got a bunch of smaller components that recreate it, all right? Another thing that's interesting about Unity versus Unreal is that in Unreal, you just have a scene view, right? You can kind of fly around and stuff just like you can in Unreal. You right-click, you look around, you use WASD to fly around, Shift to speed yourself up. But in Unity, you also have a separate game view, which will show you what the game will look like if it actually starts to play, okay? I can play my game right now using this play button. Are you ready? Ta-da! All right, worst game ever. But it is a game. I can pause the game right here. And this is one of the best features that Unity has. Unreal struggles with this, actually. You can pause the game, and suddenly I have the editor back. I can now look in my hierarchy, in my outliner, and I can move things around and tweak them while the game is still running. So I can move and rotate this brick, and then I can unpause the game, and I'm back to playing the game. Okay? This is to say that when you're dealing with a Unity project, if anything is weird or wrong, you say to yourself, why isn't this working? Well, you can pause the game and you can look at all of your game objects and all of their components to find out what is wrong, okay? And you can do experiments right there. When you end the game, you lose everything, okay? So you will need to remember what you changed so you can recreate it when the game ends. But that's the situation. It's actually very nice. One of Unity's best features over Unreal. Now, let's say I actually want to make a game. You know, all the shortcuts work the way you would hope from Unreal, okay? I can click on objects. I can go to scale mode. I can make a really big platform. This is going to be our ground, let's say, okay? A nice chunk of ground. How's that going to look for us? Okay, going to like that camera angle. That looks really nice, okay? I like that a lot. Now, we need to go get some ground. So how can we do this? Well, I'm going to go, let's get a grass texture, okay? Let's just go find a random grass texture. You're not supposed to do it this way, okay? But I'm definitely going to do it this way. So manytextures.com, I'm going to save this right here, 1.jpg. That's not a good name. We'll rename it later. Let's go in and see if we can find that file right here. There we go. Okay, and I'm going to drag it in, okay, like this. Okay, I just drag it right into my project. You see how I did that? Down here, we have the equivalent to the content drawer in Unreal. This is called the project pane. And if you ever want to add something to your reality that you're making, your world that you're making, you just drag it in. Now watch this. I've got this texture. Now I can just drag the texture right onto the object and boom. I now have a grassy little block right here, okay? And so that's pretty convenient. If you ever wonder, you know, what is my project? How is it structured in my file system? You can always right-click on a folder or asset in the project and go to Show in Explorer or Show in Finder, and you'll actually see that my project is just this folder on the disk, and I can go through and look at all my nice files, materials, scenes, everything, okay? And it is very, very nice. So, anyway, we've got this game now, and when we play it, we see this green brick. But I want to actually be able to move around and do cool things. I need a player character, okay? So, how can we do that? Well, what I'm going to show you is kind of the first assignment, the first week of EECS 494. It's a game called Rollerball. And the game is about creating this ball character and trying to navigate an obstacle course. So we're going to do more than that today. But let's get that started. I've got all these 4 game objects, and so if I want a player character, I need another one. So I'm going to create one. I go to the plus, I go to 3D object, and I want a sphere. Unity spawned my sphere in way over here. I'm not sure why it does that. How Unity chooses where to spawn things in, I don't know. But I'm going to zero out its position. This moves it to the center of the world, and that's a really good starting position. I might raise it up so it can fall a little bit when we start the game. And I'm going to run the game, and nothing, actually. Wait a second, why is it not falling? What's the problem here? I want it to fall and land on the ground. What's the problem? Anyone? Yeah. So you might say to yourself, well, I want the sphere to have physics. Why doesn't it have physics? Your mission here is to pause the game, click on the sphere, and then say, what component would the sphere have that would give it physics? And if you look, there's nothing. We have the transform, which gives it a position, rotation, and scale. We have a render, so we can see the ball. We have a sphere collider, so it can collide with things, but we don't have any component that actually simulates it, that actually gives it a velocity, gives it drag, gives it mass. And so we need to add that, okay? And so let's end the game, and let's go to Add Component. Whenever you want an object to do something in Unity, you need to add a component of some kind. If you go in here, we find a bunch of components that Unity, the company, Unity, has made for us. There's a category called physics, and in that physics category, there's this rigid body right here. Okay, rigid body is exactly what we need, okay? This component is OP, it is super powerful, you can do tons of things with it, and just by adding this rigid body onto my sphere, we're going to get all sorts of good stuff. When I run the game, the ball now falls and it hits the brick and it stops. That's exactly what we wanted, but I can also do this. I can say I'm going to move the ball back up. I'm going to rotate this brick. And note, I'm still playing the game. And I want to watch it kind of roll off. So there it goes, and it rolls, and it rolls, and it falls off, right? So our physics simulation is pretty rich here. It's pretty good stuff, okay? In fact, we could even create a second ball so that they could kind of land on each other. That could be a very interesting interaction. Let's see what this looks like. Okay, and moink. Okay, and they kind of push each other and roll off each other. Yeah, so this is a really deluxe physics simulation. It's really, really good stuff. And it's a very, very good start. Now, a question for you is, I want to control this ball. I want to be able to control whether the ball goes east, west, north, south. And so, what do I do? Because here's the problem. You could look for a component that Unity has made for you, a built-in component, maybe something called, I don't know, control. And there's a character controller, but I don't think it's actually what we want for this. There's no controller that just lets us roll. There's no component that does what we want. So, what should we do? Are we out of luck? We should make our own component. So here's what you do. You just start typing. I want something called, let's call this a keyboard control, okay? Keyboard control. And when nothing shows up, there's this option that does. It's called new script. I click on it. I click create and add. And you can see this component was just added onto my game object. This new component called keyboard control. When it's done compiling, it will literally look like any other component. Okay, but this one is called keyboard control. And I can see this script. Okay, this component is now sitting in my project pane. It's keyboard control, it's right here. If I double click it, Visual Studio will open up that component and show its guts. Okay? So what is the guts of a Unity component? It's a C# script. Okay, and you've seen this in the past. It is a C# script with some helpful comments. Start, the start function, is called once before the first execution of update after this mono behavior is created. This might be confusing to you. Mono behavior, what's that? Well, that is a synonym for component. It's really a shame that they called mono behavior what they did, because people would be much less confused if they just said, hey, after the component is created, right? Update is another lifecycle function that runs once per frame forever until this component is destroyed, i.e. until this game object is destroyed or the game ends. What are the corresponding functions? What are the corresponding concepts in Unreal Engine? Do you remember what they're called? In Blueprints, there's also a function or an event that happens at the beginning. And there's also a function or event that happens every frame. What are they called? Anyone remember? Yeah.
Begin, play, tick.
Bingo, right? So begin play is the equivalent in Unreal of Unity's start function. Event tick is the equivalent of Unity's update function, okay? And so, for instance, if we want to print a message to prove this, I can write this. I can write print, okay? And I can write starting, hooray, okay? And down here, I can write print and go updating, yay, okay? And when I run this, hopefully we'll start to see a bunch of messages, not on the gameplay screen, but in the console down here. I'm actually not going to play maximized because otherwise we can't see it. I'm going to switch it back to focused. When we play the game, we're going to see a ton of messages down here, okay? And look at that, just a ton of messages, almost 1,000 messages saying updating yay, okay? It's a little bit hard to see if you're far away, but hopefully you can see, or you can always scoot up and get closer if you want to. And at the very start, the very first message that happens is starting hooray, as you would expect, okay? So this is a really, really good start. Now, what we want to do here is we want to change our velocity when the player presses certain buttons up or down. So we want to be checking those keyboard inputs every single frame. So update is where we want to do our logic. So, how can we deal with this? Well, here's a way to deal with it, okay? I want to have an if statement, and I want to go input dot, okay? By the way, this is the part of the course where having autocomplete for your code is super important. You really need to have this. You start typing something, and it gives you your options. So input dot. When I type dot, suddenly I can see all the awesome functions and variables that are available to me, including the get key function, which is what we need, okay? Get key returns true while the user holds down the key identified by the key code parameter, okay? And so let's send something in. I want to go key code dot, and then let's see what our options are. I'm looking for right, and then we got right arrow, okay? Bingo, right arrow. So what do we want to do? Well, in order to change the velocity of our ball, we have to know where that velocity data is stored. Where is the velocity data stored? If we look at this ball right here, click, yep, there we go. If we look at this ball, we can see that it's got a position right here in the transform component, but we're looking for something related to velocity. Which component should we probably look in? Do you have any idea? Which component gave us velocity in the first place? At the beginning, we were just kind of stuck in air, just hovering in midair. But now we have velocity in our game. So where's that velocity coming from? Anyone know? Which component has the velocity in it?
Your rigid body.
That's right. This rigid body component gave us our gravity, it gave us our physics, and it also gave us our velocity. So our mission here is to have this component called keyboard control grab a reference to this rigid body and mess with the rigid body's velocity. How do you do that? Well, we're writing code inside of keyboard control right now. The way we can do that is by going get component. This is a function where we provide it with a particular type, a template type, and this function will grab us any rigid body that is on the same game object, okay? So this keyboard is going to grab this rigid body, and once we grab the rigid body, we can grab its velocity, okay? Linear velocity is what it's called, okay? There we go, linear velocity. And we're going to set it equal to what? Do any of you remember what a vector 3 is? So in Unreal, vector 3 was a variable type. And a vector 3 was a 3D point. So x, y, z, okay? This linear velocity variable is a vector 3, which means we need to create a new vector 3. So we'll go new vector 3. And then when you look at the constructor, for the vector 3, it needs an x and a y at least, but it also wants an x, a y, and a z, okay? So we'll do that. We will go and give it, x is right and left, so that makes sense. We'll give it a 1, a 0, and a 0, okay? So when I press the right arrow key, we expect to go 1, have a velocity of 1 on the x-axis. Which one of these is the x-axis? Well, you can look at this gizmo in the corner and see that x is to the right, y is up, and z is forward into the screen. Z and y are flipped, okay? In Unreal Engine, z is actually up and y is different. So let's see what happens, okay? So I'm going to run the game. I'm not pressing anything, okay? Not pressing anything, and then right. And I start to move. So that's pretty cool, huh? But there's a bit of a problem. I'm floating, okay? Well, that's because we are setting the velocity raw, which is not what you want to do, okay? If the player is falling, then they have a y component to their velocity. But here, we're setting that to 0, and we don't want to do that. So another thing we can do is instead of setting the velocity directly, we can do this, dot add force, okay? This is a function that takes a vector 3 but adds it as a force. Instead of setting the velocity, we're just augmenting the velocity, okay? And so there we go. And now we can also do this for the other directions as well. So we're going to have right and left, and we're going to have up, and we're going to have down. And I'm just changing the inputs. This is why copy and pasting is dangerous. So I didn't change these numbers, all right? So if we want to go left, we need to go -1 on the x-axis. If we want to go up, then we need to go not at all on the x-axis. We need to go on the z-axis, okay? And down is -1 on the z-axis, all right? And so let's see what happens. If we want to jump, we need to do things on the y-axis. But we don't care about jumping right now, at least not yet, okay? Okay, so I'm pressing all these buttons, and look at that, right? And I can move around in 3D space now, at least on a 2D plane, okay? So good, very good. But here's a question. What if I wanted to go way faster? That speed was really slow. What do I have to do now if I want to go faster? With this code, what do I have to do? It's very annoying. Any idea? Yeah, right? So my big problem is that I want to go faster than 1 when I press these buttons. So I could replace this all with a 2, but I'd have to do that 4 times, and it's really annoying. So here's what I'm going to do instead. This is one of the coolest features of Unity. You remember how in Unreal Engine, you could make a variable and then click the little I to make it observable, right? That allows you to edit the variable in the Unreal Editor without writing any code, right? Well, here's what we can do. I'm going to create a public variable. I'm going to call it public float, okay? Float is different than a double. It is a decimal number, but it's smaller, right? And I'm going to make this a default of 1, okay? Let's call this, what should we call it? Let's call this movement speed, okay? And this movement speed variable, we're going to plug it in for all of these 1 values. Now, if I want to change the value here, the speed, all I have to do is change this variable. But I'm not going to do it here, okay? I won't change the variable in the script because this variable is now going to make a dramatic appearance. You see, the variable has appeared in my Unity editor. Whenever you make a public variable in Unity, that variable is going to show up under your component. So you see all these built-in components, you now know how they were made. They were written in C#, and all of these variables right here that you see, right, they're just variables in the script that are public, okay? And so you are kind of doing the same work that the actual Unity devs in San Francisco are doing. So I'm going to set this to 2, and let's see if it's a faster movement speed. I'm going to make my platform a bit bigger too, so I don't immediately fall off. Okay. Okay, so we're running, and I'm going to press left. Oh, we're going much faster now, right? But let's say that you're playing the game and you say, I want to go even faster. Well, you can pause the game, go to that component on the sphere. I'm going to make it not 2, but how about 20? Okay? Now I'm going to unpause the game. Are you ready? Okay, pay careful attention to this. Okay? Whee! And I fly away into the horizon. All right? So here's the deal. You can change your variables at runtime while you play the game to experiment, right? To find out what is the most fun configuration. And that's one of the superpowers that Unity has. You can edit things and experiment while you're running the game. It is super, 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 super cool, okay? So, in any case, we can now move the ball around, but we have a problem, okay? What if I want to explore? What if I want to leave? Maybe there's something over here in this corner that's really cool. How am I going to see it? What do I do? Well, I want you to think about it a little bit. And I want you to think about the fact that in Unity, you've got your platforms, those are game objects. You've got your sphere, that's a game object. But your main camera is also a game object that has components and that we could move as well, okay? And so I want you to think about that because we're going to take a break for 5 minutes. When we come back, we are going to do some more features, okay? And I'll talk more about how cool Unity can be, okay? See you in 5 minutes. Okay.
So, simulate.
You should put a data comment tells us all stuff strict. In that way, we'll yeah, we should be able to grade that. Okay, ladies and gentlemen, let's get back to it. So, we have our ball here, and there could be an amazing world over here for people to see, for people to explore. There could be goodies to collect. There could be all sorts of things to find. There could be an awesome map happening out here, but no one's ever going to know because we can't get over there. When we go to explore in any sort of direction, we get left behind, okay? Our camera game object, right? Our ball is headed off way to the west, but our camera is still just stuck over here, just kind of chilling, okay? Just kind of hanging out and not doing much of anything. So you might say that we wish our camera would follow some sort of target, okay? We wish we had a way to make one game object follow another game object, right? And so, what can we do if we want that to happen? We're looking at this camera. We wish there was another component, maybe called follow target, okay? If it doesn't exist, what can we do? Well, we can create it. So I'm going to create a component called follow target. Indeed, it does not exist, but we can go in there and we can create it ourselves. So, follow target, a new script. What is this target meant to do? What is this component meant to do? Well, it has to move us. It has to move us to a certain location, all right? So, every frame, we want to move our camera. Where do we want to move the camera to? Well, we want to move it to the location of that player, that sphere, right? Now, how do I get the sphere? Any idea? Well, remember, we can create public variables. And if I create a public variable of type GameObject, and if I call it target, watch what's going to happen. This follow target component down here, when we're done compiling, boom, it gets a new slot, a new target variable shows up, and I can now grab my sphere, and I can drag my sphere down and in. Now, you see, my target variable will be the sphere, okay? This is literally the sphere right here, okay? And so now that I have the sphere, we just need to move ourselves to it, okay? How do we do that? Well, if you look at this game object, this camera, the way that we control where something is by using the position data within the transform component. We can make it move up, down, left, right, forward, and backward, okay, all that good stuff. And so we need to get our own transform and change these numbers, okay? How do we do that? Well, as you saw previously, we can use getComponent, and we can specify the component's type to get that component. As soon as we run this line of code right here, we will literally have a reference to that component, okay? And a reminder, all of the code we're writing is in this component, which is right next to the component we actually want to mess with, okay? And so we're going to get that transform, and we can set our dot position to whatever we want. We can even get the information from the target, okay? Now notice there's something interesting here. We can go target.transform. We didn't do get component transform. The reason we didn't do that is because .transform is a shorthand for get component transform, okay? In fact, we can just write this. That's valid. The reason that there's a shortcut for getting the transform component on our game object is because it's so common. It's extraordinarily common. And every game object is guaranteed to have a transform, and so we're good, okay? Target.transform.position. So this line of code says, hey, set our transform's position to that of the ball, okay? And so we're going to move with that ball, okay? I want you to think about what this is going to look like, all right? So I'm going to maximize the screen so you can see better. Okay, we're going to play the game, and what happened? Where'd our ball go? You see our shadow right here? And as I move the ball, the camera is moving, so that part is really good, okay? I just went down the ledge, and now I'm about to fall. What's happening here? Does anyone know what's happening? Why does it look so strange? I can't even see the ball. Maybe it's invisible. Yes? Bingo! And this is a reminder. Whenever something confusing or unexpected happens in Unity, you always pause the game, click that little button, go to the scene view, and look around, see what you can see. In this case, our camera is inside of the ball, okay? Of course, that makes sense. Because our logic says to take your position and make it the ball's position. Or, sorry, take the target's position, the ball, and make it our position, okay? And so that logic is too simple. It's not what we need, okay? We need logic that's a little bit more advanced. So here's what I'm going to do. We actually need to go to the target's position plus some sort of offset, okay? This offset should be a vector 3. We'll make it public so we can alter it. I'm going to call this offset, okay? This will start as 0, 0, 0, so it will look no different, okay? But let's play this in the frame, and I'm going to play this. The camera is going to go inside the ball again, like it just did. But this time, our component has this follow target, the follow target component has this nice offset vector 3. So I can change the X, the Y, and the Z. I want to go backwards, so I'm going to drag and change that negative, that Z to a negative value. I'm going to change the Y to bring us up in the air. I'm going to raise that, and look at that. We now have the X, Y, and Z for the offset that looks really good, okay? Now, when I end the game, I'm going to lose those values. So what should I do? I'm still running the game. I made these changes while I'm running the game, so I'm going to lose those changes. What should I do? Well, here's something you can do. You can either remember these numbers and punch them back in, or you can do this. I'm going to click on these little dots on the component. I'm going to go copy the component. I'll end the game, so I lost my numbers. You see? They're gone. But I can copy and paste those numbers back in, just like that, okay? And now, when I run the game, we're back in business, okay? Very good. Now, we can explore a gigantic world. We can roll around and have a good time. But I'll tell you, I'm a little bit bummed, okay? Because I'm just a boring gray ball, okay? I want to have a cooler character, okay? I want to have a character that is brave and courageous and respected by all, okay? I'm thinking that I want to make a game, a fan game, about Shrek, okay? So this is going to be the next Shrek film, except it's actually going to be a game. We're going to put Shrek into our game. The question is, how do we do that? Now, you had to download 3D models from Sketchfab for your Unreal Engine project, okay? For your NPCs, right? And so I want to click this downloadable checkbox, and I'm going to look for a Shrek that I can download. I'm going to look for a really cool one, okay? This one looks like it's got a pivot point that's wrong. He's kind of spinning around his left shoulder. So that looks like it's all sorts of trouble. I'm not sure if I want that one. This is a much more centered Shrek. It has a lot of downloads. A lot of people really like it, it seems. And so let's take a look. Let's see if we can get a file format like FBX, okay? Let's see how that works. All right, we got Shrek here. Download 3D model. Oh, I have to log in. Oh, what a pain. Okay, here we go. Okay. This does not look like Shrek to me. Sketchfab loves to do this. I think it's just a Firefox glitch, but you have to refresh to get what you wanted. So now let's download the 3D model. We could try an OBJ, but I don't want to. I don't want to waste time. Let's try instead. Let's go for an FBX, okay? Make it downloadable, but I want to find an FBX if I can. Yeah, so that one's tough. What about this one? That one looks pretty good. That's a huge Shrek model. My goodness. Okay. Let's download it and see what we get. Download blend. Okay. Does anyone know what a blend is? So that is a Blender 3D file format. You could easily open this in Blender. You can open them all in Blender, but this is the easiest. Blend will work. It will definitely work. And one of the reasons it will work is that it is, when we bring it into our Unity project, Unity will see that is a blend file, and it will open it by exporting it to FBX, okay? This is a very annoying file format. So here we see source and textures. And so we've got our blend file right in here, and hopefully it'll be able to find everything okay for us. Got all those textures right in there. So let's do this. I'm going to grab and drag this folder right in, okay? I'm going to create a new folder for characters. Okay, create a new folder for characters, and now I'm going to drag that Shrek 3 folder right in, and we'll see what we get. Sometimes Unity can import a 3D model super well, and it looks amazing without any fix-up needed. But sometimes it's a disaster. So here it's saying, hey, yeah, we weren't able to find certain textures. So let's fix now if we can. Can it? Maybe not. So we've got our Shrek object, Shrek.blend here, and I think I can drag it into my scene, right? Yeah, no. Let's see here, model, let's go to model, apply rig animation materials. Okay. Let's go to materials. Okay, extract materials. Okay. Okay. So I really, why can't I drag you in, Shrek? Oh, it's because it's the game view. Yeah, you can't drag anything into the game view. You have to drag things into the, oh my goodness, the scene view. Shrek is gigantic, large, and in charge, okay? He also looks like he's made of plaster. What's the problem here? What's going on? Anyone know? Did anyone see something like this in Unreal Engine? Yeah, so what's the problem? Yeah.
So this depends on the original quality, how they render their models.
Possibly. Right now, the main problem is that our materials have lost association with the textures that they need, okay? These materials right here, okay, they have these base maps that just aren't filled. They're just a color. So what we need to do here is we need to go to these materials and we have to find the right texture to drag and plug in here. So what I'm going to do is I'm going to lock this inspector right here so that it won't change when I click on other things. Now I'm going to go and try and find his eye texture, and I think I found it. So I'm going to drag this eyeball texture in, and did we get any effect? Maybe? I didn't see anything. You see anything? Yeah, I don't think this changed. Let's see if messing with these will help us out. Let's go back in here. Let's go here. What will this do? Make it red. Oh, goodness. Okay. I kind of actually like that. But for now, we're going to try and plug in the eye into that material. Nice. That looks much better. Okay. You can even take this eye texture and you can tint it by tinting the material red like this, right? So now it's like a Shrek demon. And so let's go and look at these other materials. This is shrekbody.material. So I'm going to lock that. Let's go find the texture for it. Here's Shrek body color. So I'll drag that in. Okay, that's looking not too bad. All right. Okay, those fingers aren't looking super good. Okay. We have a normal body normal file. So I can bring that into the normal map right here. Okay. And so let's go deal with our other materials. So we got this material that's messed up. This is another body material. So let's go ahead and drag that body right in here. Okay, I didn't notice much of anything happening. Maybe his legs changed? I don't know. Let's go and do the next material right here, Shrek Body 02, another body material. This is a very annoying model to fix up. Okay, his coat, his little overcoat is now looking much better. Okay, unlock this. Let's go to our next material, body 3. It's just all body stuff. Wow, we're going to get to face eventually. Okay, that one didn't seem to make a huge difference. Okay, let's go to Shrek body 4, lock that, go to the material, drag it in. We're just fixing up our materials. That made a huge difference. We got Shrek shirt going on here. Okay, and then we got 2 more materials, Shrek body 5. So drag that in. Okay, shoes. And then I'm guessing the next one and last one is face. Yep, Shrek head. Okay, so let's go find the texture for the head. That looks like it. Yeah, is this spooky to anyone else? Yeah, maybe? Okay, you saw the human one, right? If you wake up in the middle of the night and in the darkness you see this, you just go back to sleep as fast as you can, okay? And don't try not to pay any attention to it. So I'm going to drag this in right here, and there we go. And we've got our demon Shrek, and he actually looks like a demon. So this is great, okay? Very good. All right. So this is still way too big, this model, all right? Way, way, way too big. So when I click on the actual model here, the .blend file, I have a lot of options, okay? Gonna let my inspector go. The inspector will show me a bunch of different categories up here. One of them is called model, and there's a scale factor. So I'm gonna change the scale factor to 0.1, so 10 times less, and click apply. Watch what happens to Shrek. Wow, okay, he's gotten a much, much smaller. But he's still not small enough, right? I want this ball to be about the size of Shrek. So I'm gonna go in and let's make him even smaller. So 0.2. Okay, let's try that. Is that going to be small enough? Okay, that looks about right. So this Shrek object has a camera on it, so I'm going to turn that camera off, okay? Otherwise, we'll have a lot of problems where the camera kind of steals our main camera away from us. And I'm going to take this Shrek model, and I'm going to do something to him. I'm going to take this Shrek model, and I'm going to show you something that is very different from Unreal, okay? In Unreal, parenting is kind of hard to do, but in Unity, it is super easy. This Shrek game object right here, I'm just going to click and drag it under the sphere. So now Shrek is parented to the sphere. When the sphere rotates, Shrek will also rotate. He now has a gigantic stomach, right? But I don't, that actually looks shockingly good, right? Like it kind of is part of the model. But I'm actually going to take this sphere, and I don't want to be able to see the sphere. I still want the sphere. I just don't want to see it. So I'm going to take the sphere, look at its components. Oh, it has a mesh render. I'm going to turn the mesh render off and look at this. Suddenly, boom, it's just Shrek, okay? And now, when I play the game, let's see how it looks. Incredible, okay? This is clearly the next big game. You know what's really funny, though? Why is my lighting getting all weird? Do you see this light? Let's see if I can get it back here. You see that light right there? It's like a little spotlight on the ground. Do you see it? So you might be suspicious, I added this model and suddenly my lighting is all super weird. Well, if we pause the game and look at Shrek, if we look inside of Shrek, we can see that, yeah, his eyes and stuff are here, his model is here, but there's a light, there's a sun in here, okay? So the Shrek model came with a camera, which we turned off, but we did not turn off the light that came with Shrek. So I'm going to go in and I'm going to turn that light off. So the light is gone, and now we should be able to roll around in peace without getting this nasty glare in our eyes sometimes. Okay, there you go. You've got Shrek doing cartwheels to save the day, which is exactly what I was looking for in the next big Shrek film. Okay. Anyway, so one problem we've got is that we can roll around, and that's pretty cool. But how do we jump? Well, you could say, I want to jump with the space bar, right? But how do we do that? we might think, well, it should probably be some logic that we add to our keyboard control, right? Because the keyboard control component is currently allowing us to move, right, left, up, and down. But what happens if we want to be able to press the space bar? Well, we could do it like this. If input.getKey, keycode.space, all right? Then we want to do something. What do we want to do to launch ourselves up into the air? Anyone know? Yeah. Okay, yeah, we could add a force. Yep, that's one way to do it. Let's give it a shot. Now, this is going to have to be a pretty big force, okay? Because we're not holding it down so much. So let's go upward. Let's make this 100. Get rid of our movement speed. If we're going to program really high quality code, we probably don't want to hard code a 100 here, because maybe we decide that we want to jump higher or lower. So we should actually make another public variable. Let's go public float jump power equals 100. And now, instead of having 100 hard coded here, we can have a nice variable that we can change whenever we want. Okay? So let's make sure that variable shows up. Okay, we'll take a look at it. Boom, there it is, 100. And so now when we run the game, I'm going to press spacebar real quick. Okay, ready? Boop. And we do a pretty good jump, right? That looks good. Now, question, what happens if I hold the spacebar? Anyone know? I'm going to hold the spacebar this time. Ready? 3, 2, 1. So that wasn't really what I was hoping for, okay? Not really what I wanted. So we have a problem. We have a problem. Our code just lets us jump continuously even if we're still in the air. There's no check in our logic that says, hey, are you on the ground? If you're on the ground, you can jump. So what's one way that we can detect if we're on the ground? Well, do you remember in Unreal Engine how annoying collisions were? I will say in Unity, they're still annoying, but they're less annoying. In fact, I would say they're quite a bit better, all right? So here's what we're going to do. We're going to have a Boolean, okay, bool. This is not going to be public because we don't want people changing this. I'm going to call this on ground. And when we start the game, it's false because we're in the air, okay? We kind of fall down. Now, what we're going to do is we're going to write a function called onCollisionEnter. This is a special lifecycle function that Unity has. It's very similar to the collision functions, the collision events that you used in Unreal. Like, I think it's onHit. Did you ever see onHit? OnOverlap, right? And so right here, what we're going to do is we're going to say, hey, you hit something, you probably hit the ground, so we'll set ground to true. But if you ever press the space bar to go up into the air, we're going to assume you're off the ground and we're going to set it to false, okay? We're also going to say that you can't jump, okay? You cannot jump unless you're pressing space and you're on the ground, okay? And so there you go. Our logic has gotten a bit more complicated, but we're detecting collisions now, and we're using those collisions to decide if we should jump or not, okay? So let's test it, all right? I'm going to tap it to see a normal jump. Ready? 3, 2, 1, tap. Well, that's a very tiny jump. Wow. Tap. And now I'm going to hold it down. Ready? 3, 2, 1, hold. And I just kind of keep jumping. Good. This is much better, but what's the problem here? Our jump kind of stinks, right? Like, this is very underwhelming. I'm going to pause the game so I can keep experimenting. I'm going to go to my component and say, you know what? How about not 100, but 1,000? Ooh, nice. Okay, I'm going to hold it down, holding it, and we go back up. Very cool, but that's too much. So I'm going to experiment now with something like, I don't know, how about like 400? Okay, let's try that. See what 400 is like. Okay, ready? 3, 2, 1, hold. Looks pretty good. That is a nice, modest jump, okay? Shrek looks like a very spry character. but I would say that that's about the jump I would expect from his character design. And look at how fast we can get him somersaulting. It's amazing. Wow. Okay. And so we have the beginning of a pretty cool feature set here. Okay. Now, what else might one want to do? What else could we maybe do? What about a collectible? Okay. What does Shrek love to eat? Doesn't he love onions? Because like an ogre, onions have layers. Okay. Now, a lot of these look really expensive and big. Okay. That's an amazing looking onion. Okay, let's try and get that one. How easy is this one going to be? Another blend file. Let's do it. Okay. Oh, why is it shiny? Oh, we're going to have to turn off the light. This thing comes with a light, guarantee it. So we're going to have to remember to turn off that light. Okay. Well, I'm going to download the blend file, and I'm going to go in to it, and I'm going to unzip it. All right. And let's do that. Right? And let's go ahead and I'm going to drag this. The onion isn't really a character, so I'm going to create a new folder for objects. Okay. And now we're going to just drag our onion right in. Okay. Going to drag the whole folder right in. See what happens. Okay. Onion, go into source. I'm going to drag the onion out here. Okay, that's a huge onion. It also doesn't look quite right. So I got to do what we did last time. Click on the onion, go to materials, extract materials so that we can edit them. And once they're edited, only one material. That's great. I'm going to lock it. I'm going to go and look for the texture that is missing. And here you go. Here is the onion base color. Okay, there's our nice onion. And we have the onion normal map, which I'm also going to plug in. Okay. And there we've got our onion. Heck yeah, there we go. All right, looks good. And so this onion is too big, so I'm going to go and resize it real quick. Go to onion. Now we could take the onion and make it smaller via its transform like that, but I don't want to do that if I don't have to. So I'm going to go 0.1 maybe, see how big that is. Okay, that is a very nice size for a collectible in our game, okay? So this is fantastic. Now, I want to put, I don't want to have one onion. I want to have 20 onions, okay, in this level for us to grab. So what I'm going to do is I'm going to make something that is very similar to a blueprint, okay? Right? Remember what blueprints are for. You have, one thing, you turn it into a blueprint, and now you can put that thing out there 1,000 times, right? What we're going to do is we're going to create what's called a prefab, which is, let's call this onion prefab. This is basically the same thing as creating a blueprint in Unreal. So I create this prefab, and now I can drag it out there, and I can change all of these onions just by going into the prefab and making it larger, okay? And I change all of them, all right? Makes super weird, creepy prefab, okay? Creepy onion. Now, I want to be able to collect these onions. If I look at the onion prefab, all it has is a mesh render. What does that mean? Well, it means that I can't collide with it. I'm just going to go through. So we need to improve this onion. I'm going to double click on that onion prefab so we can just edit it really nicely. Why is it blue? There it is. And I'm going to say, well, we need a collider, okay? Collider components are what give collision shape to an object. This onion is a sphere, and so I'd really like to get a sphere collider if I can. Now, we got a bit of a problem because this sphere collider is now 10 times the size of our actual onion. That's going to look super weird if we leave it like that. So I'm going to take the radius value and I'm going to just kind of drag it down until it kind of fits the onion a bit better, okay? And it's still a little bit big, so I'm just going to bring it down a tiny bit more. Let's 0.1. That's a really good fit. 0.11, okay? Super nice fit, and that's going to be much better. So let's go ahead and run the game now. Now, when I run the game, I'm going to bump into these onions. Now, the onions don't move. I guess they're way tougher than we are. But what can I do if I want them to move? Yeah, rigid body, right? If you remember, Shrek got his physics when we gave a rigid body to his object. If we go to the sphere, which, by the way, I should rename the sphere to player, finally, okay? And if we look, we've got that rigid body right there. So I want to go to my prefab, because I want to add this rigid body to all of the components, not just one or two of them. Oops. And I'm going to add that rigid body, and thus every onion will now have the rigid body. Boom, you can see it right there, okay? I'm going to add an onion that falls from the sky just so we can enjoy the physics of it all. And then I'm going to roll around and see what happens, okay? Okay, rolling around, and I'm pushing the onions. Yeah, this actually feels like a Shrek game now. There you go. Okay, there we go. All right, there you go, right? So, not too bad, huh? But if these are meant to be collectible objects, then we probably want them to disappear when Shrek touches them, right? Shrek is grabbing them, putting them into his inventory, and it's a good time. Well, how are we going to deal with this? Do you remember how we detected when we touched the ground? That on collision enter function, can we use that again? And I think the answer is yes, okay? So on Shrek, or on the player, actually, I'm going to write a new component. This component is going to be called collect onions, okay? And this component is going to have that on collision enter function in it. And we're going to use that to detect that we've touched an onion, and we're going to destroy the onions as we touch them, okay? So let's use that on collision enter function, and when we touch something, we want to destroy that thing. So we can use the destroy function. I think it's literally the same function call in Unreal. It's called destroy, or destroy actor. And I want to destroy not the game object, because you know what game object is right here, this variable? This is a default variable you can always use in a component. You know what this is? This is the same thing as the getOwner node in Unreal. This gets you the reference to the game object that you are currently on. So if this collect onions component destroys game object, what it is doing is destroying the player. So this happens. Oops, now our player's gone. Okay, so you have to be careful. What I want to destroy is hidden in the collision. So in this collision object, if we type it, we can go dot, and we get game object. So this is the game object whose collider you are colliding with. That's exactly what we want, okay? Now, I'm going to run this game, and I want you to pay very careful attention to what happens, okay? Watch very carefully what happens. Okay, ready? We're going to go bump into those onions, and we're going to destroy those onions when we touch them. Ready? Oh, no. What happened? I did get one. Yeah, it worked. I did destroy an onion, but I'm sorry to say something else happened too. What happened? What's the fly in the ointment? Our logic was naive. Yeah. Yeah, I'm destroying everything that I touch, and that's not what I want at all. Okay? Not at all. So the question is, how can we figure out if the thing we touched is an onion or if it's something else? If it's an onion, we want to do our logic, but if it's something else, we do not. We could check for the name of the object. We could go, hey, if collision dot game object dot game object dot name is equal to, what is it? Onion prefab, okay? We could do this. It's not the worst idea in the world, but the problem we're going to run into is that we have a bunch of onions. We have onion prefab 1, onion prefab 2. They all have different names, and that's a big problem, okay? And so we need a different way to deal with this. Well, if we go to the onion prefab right here, double-click the onion prefab, there's this system in Unity called a tag, okay? You can see that currently the onions don't have any tag. there are some default built-in tags, but I can create a new tag, and I'm gonna create a tag called onion, okay? I'm gonna save that tag, that onion tag, and when we go back to the prefab, I can actually say, hey, prefab, I want you to have the onion tag. So now every onion we look at will have that onion tag, and we can make our logic more sophisticated. We can go collision.gameObject.tag, and we can ask if it is the onion tag. If you've got the onion tag, then you're getting destroyed, okay? But if you don't have that onion tag, you're not an onion, so we're not going to destroy you, okay? So hopefully our ground will stick around now, and we can go munch up these onions, okay? So there you go, and I'm going to bump into the onion, and boop, onion's gone. Boop, 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 boop. Rock and roll, okay? So the takeaway here is not that you need to know how to do everything I just did, okay? The takeaway is that you can do some really cool and fun stuff in Unity shockingly fast. Because like this is kind of a cool little game. You could make some cool level designs here, you could add some more blocks, right? Add some challenges, more onions to collect. And you could send this to a friend and see if they have the skills to get through it, and they'd have a good time. But notice, this took us about 30 minutes to make, and I was talking to you for about 60 to 70% of that time. I could have made this right here probably in about 5 to 10 minutes, all right? And you will be able to make things like this very quickly as well, okay? Because your next few weeks, your next month or so, even across spring break, you're not supposed to work during spring break, okay? We gave you extra time so you don't have to do that. But like for the next month, you're going to be diving into and learning Unity, one of the most famous game engines in existence. It is the younger brother, lighter weight, right? But maybe more agile, okay? A little bit more elegant, a little bit more polished than Unreal, okay? And you can do some really, really, really fun stuff, okay? If you can do something in Unreal, there's a way to do it in Unity, but usually the name is a bit different, okay? So for instance, a line trace in Unreal is called a raycast in Unity. And if you want to know how to do it, raycast, Unity. Unity is famous for its incredible documentation. Right, you get a description of the function in C#, but you also get a lot of really good examples, example code that you can just use to show you how to use it, okay? GPT and AI assistants are vastly better with Unity and C# and helping you figure out what's going on and how to do things than they are with Unreal. In Unreal, it's like, here's a node that might be useful. And, you know, you should hook it up in this fashion, but it can't generate a picture for you to show you, right? In C#, it actually can, because it's all text, it can help you much more effectively. And I encourage you, when you get stuck or confused in C#, when you wonder what a function does, or, hey, GPT, what's the best practice for doing a jump? The AI assistants, especially for that early beginner level stuff, is going to really speed you up, okay? And most importantly, if you're ever confused about something, right? Hey, GPT, I wrote this code, but I don't fully understand why it works. GPT is very good at kind of breaking it down for you and helping you understand what each little piece means, okay? Basically, it's pretty decent quality office hours that occasionally lies to you. But then again, like sometimes I say something that's wrong. Sometimes our staff says something that's wrong. Okay, or makes a mistake. So what I encourage you to do here is take a rest for the next 5 days or so, do your postmortem, but I hope you're really excited to learn about Unity. It's probably my favorite game engine. It is extremely popular, especially in mobile games, but also in indie games as well, right? The games you find on Steam, on itch.io for under $10, that's almost certainly a Unity game. And you are going to use Unity for some really cool stuff. We're going to make a Pokemon Go clone, not entirely from scratch, but I think you're really going to be very impressed with what the engine can do, okay? So, everyone, congratulations on completing Project 1. You've earned a break. I hope you will take a break, okay? And we will see you on Monday to start into the world of AR and Unity, okay? Take care, everyone. If you need office hours, I'll be here from 6 to 8 p.m. tonight. Please be careful of the snowstorm. Stay warm, and I'll see you next time. Bye-bye. All right, everyone online watching on Twitch, take care. Thank you for joining us. All of you on YouTube as well. We will see you later, okay? Stay warm, and bye-bye.